converts the stored kinetic energy into electrical energy, and that is quickly dissipated in the resistance. If you simply disconnect the supply, DC motor takes a long time to stop. It is very interesting to observe in your machine's lab. You stop supply to induction machine, you stop supply to DC machine. Induction machine stops quickly, comes to zero speed. DC machine takes a longer time to come to zero speed. What is the reason? You apply brake for your two-wheeler, you apply brake for your lorry. Two-wheeler can be quickly stopped, but lorry stops after a long distance. Because the inertia of the lorry is much higher than the inertia of the two-wheeler. So, inertia, DC machine, the bulky armature winding is kept in the rotor. Because the bulky armature is in the rotor, the inertia of DC machine is much higher. That is why DC motors takes long time to start and takes long time to stop. So if I disconnect the supply and then close the switch to position 2, then this energy which is stored, kinetic energy, is dissipated and quickly the rotor stops. That is dynamic braking applied to DC machine. Regenerative braking, it works as a DC generator and feeds power to the source. There are some conditions for regenerative braking. Conditions: the machine should act as a generator and the converter there should act as an inverter to feed the power to the supply, and grid must be in a position to receive. Let us say you want to give loan to somebody. Some idiot should be there to receive that money because you want to give loan at some 36% interest. Money should be available. You should have the heart to give them money. And some idiot should be there to take the loan. If these three conditions are satisfied, this finance business will continue. Like that, you want to regenerate power, power should be available, machine should act as a generator, and grid should be in a position to absorb the load. If these three conditions are satisfied, then power can be regenerated. So, plugging in series motor, I am keeping field terminals like this, then I am reversing the field terminals. Here I am reversing the armature terminals. Field I am not disturbing. GH here, HG. So if I reverse the armature terminals, then plugging takes place. This is used in electric traction. Synchronous motor, you have studied about synchronous motor. Conventional synchronous motor, the speed is constant. So torque versus speed, if you don't have any controller, this is the characteristic. And then you have seen torque angle curve, P versus delta, T is Tm sin delta. This 0 to 90 you call it as stable region, 90 to 180 you call it as unstable region. So in a synchronous motor, if you operate between 0 to 90, it cooperates, you increase the load, power developed increases. But beyond 90 you increase the load, but power developed decreases. That is not possible. It is something like your behavior in the normal days and your behavior in the examination days. So you are very stable now. You want to work more, you eat more. You eat nicely and you work, you are stable. During examination times you are unstable. You work more but you eat less and you become sick. So that is what happens beyond 90 degrees. Beyond 90 degrees, you are increasing the load of the motor, but the power developed is decreasing. That is not possible. So, the lock between the stator and rotor is lost, and the synchronous motor pulls out of stack. So, it cannot run between 90 to 1. So, there is another type of synchronous machine called salient pole type. In salient pole type, you have an advantage. You have the normal power and you have reluctance power. Because in salient pole machine, your air gap is not uniform. You have projected poles. Your rotor poles are projected, it is not a round rotor. So you get some extra power, that is called reluctance power. So your normal power plus reluctance power. This curve is reluctance power, this is your normal power. So if you add 1 and 2, you get the total power. So if you take a particular machine of same size, then the power developed by reluctance motor is higher than the power developed by a salient pole type of machine is higher than the power developed by cylindrical machine. So this is what you have studied in machines. The first unit is a quick revision of what you have already studied in the machines. So we'll give some introduction to induction motor drives, solid state induction motor drives. So we said the field is rotating RMF, rotating magnetic field rotates at synchronous speed, and rotor rotates at a slightly lesser speed. So we said it is similar to cat and rat race. We assume that rat is running at a higher speed, so the cat always tries to catch the rat, but it cannot. In the process, the race continues. Or you can put human being here and money here. So the inflation is higher than your earning rate. So we are always running behind the money. So with solid state drives, we can control the speed of this rat or control the speed of the rotating magnetic field. Therefore, we control the speed of the rotor. So we are going to talk about voltage control, then V-wave control, then rotor resistance control, then slip hour. These are the 4 things we are trying to cover. I think the third item we have already covered. Rotor resistance control we have covered. We gave the example of load. So voltage control, very first thing, voltage control. What you are using for your fan regulator uses voltage control. So in your fan regulator is cheaper. With your fan regulator, electronic regulator, you can go for energy saving. So when it comes to induction motor, we talk about energy saving. So what I mean by energy saving, the operator in the factory, he will come and he will turn on all the motors and he will use whenever that requirement comes. You have a lathe machine, you have punching machine. So early in the morning the operator will switch on all the motors. Whenever punching is required, he will use that running machine or drilling machine. So what is the concept of energy saving? All the drives manufacturers, ABB, Allen Bradley, all these people are putting in their brochure energy savers. So what they mean by energy saver, they are using a voltage controlled induction motor plant. So whenever you are not using the load, reduce the voltage to the induction motor. In a badly designed induction motor, the no load current is 40% of the rated current. Induction motor is not doing anything like us, but drawing 40% of the rated current. So my current I is V by Z. If I reduce the voltage, my no load current will be reduced. So energy saving concept is very simple. Apply 2 alpha system or 2 voltage system. No load condition, you apply low voltage, current drawn is reduced, and if the current drawn is reduced, then the losses are reduced. Whenever you are loading the machine, then you apply full voltage. So that is concept of energy saving. It is simple control. Disadvantages with your voltage control, limited speed range. You really don't get good speed range. At home you struggle with your electronic regulator. At home you have a fan. In the winter you are struggling. If you use electronic regulator, if you keep at very low speed, it will stop. If you try to put some slightly higher speed, it will go to the full speed. You have very good speed control if you use rheostatic regulator, but power loss is higher. But if you use electronic regulator, you don't have good speed. You don't get easily. It is not controllable. So voltage control method, you see the demo in your lab. The speed control is not really so easy. EMI. So what is EMI? What is EMI? What is the type of waveform you are applying? The type of waveform that you are applying is something like this. In AC chopper, you are chopping the waveform. Field theory says any waveform like this has plenty of energy, it releases electromagnetic waves. So if you have a fan regulator in your house or a mixie which has got a voltage controller in the mixie, so you consider some old TV or old radio kept near this mixie or the fan regulator. Then whenever you operate the regulator, the screen of the TV will be shaking, or radio will be giving noise, unwanted noise. So the electromagnetic waves from your power electronic circuit links with this, and interference is produced. If you are living very close to the main road, olden TVs are not fixed with EMI filter. Whenever a bike or car is moving on the road, your TV screen must shake. Because in the car, in the bike, you have spark plug, you have the current, which has a lot of harmonics. Those harmonics produce fields. Those fields mix with your TV and produce interference. Whenever you switch on your tube light, in the tube light you have two electrodes. Between them you have the convection current, which produces electromagnetic waves, which produces EMI. So these are all the examples for EMI. And you can reduce the EMI by putting filters in the equipment. All modern TVs, modern radios are fixed with EMI filters. So one of the drawbacks of your AC chopper is EMI. So you have half-wave control. Half-wave control, one is SCR, other one is diode. So this is the type of waveform. This is not used in practice, because if you apply this type of voltage, this voltage is unbalanced. The positive area and negative area are not equal. You will have harmonics. Because of the harmonics, you will have more heating in the induction. This is a better method. You can have windings like this. You can have a delta connected SCR system. You can trigger the SCRs and control the. The most popular is this 3-phase AC chopper. Single phase AC chopper, at home you have only one anti-parallel SCR. Here you have 3 anti-parallel SCRs in the 3 lines. So this is what I was telling about energy saver. What ABB or Allen Bradley is selling, what they call energy saver. So this energy saver is nothing but 3-phase AC chopper, which converts fixed AC to variable AC at speeds. You clearly see if you take a fan load, and then you see these voltage curves, the range is very limited. This is what I am trying to say. You really struggle if you have an electronic regulator. But I request you to recommend electronic regulator, because we have power shortage problem. If you use rheostatic regulator, you have power loss. Please replace all regulators in your house with electronic regulators so that your electricity bill will be reduced. So recommend AC chopper. So this is closed loop controlled chopper bed. This is the chopper, this is the induction motor. This is the closed loop controlled induction motor drive. I will explain one closed loop in detail. Like this, you will get some 40 block diagrams in your subject in this semester. If you understand one block diagram, same theory you can use for all the block diagrams. So it is something like the movies. 30 years back you see the movie, then 20 years back and the present movie, all the same story, only the hero and heroine will be changed. But the movie remains the same. So our block diagram remains the same. Our block diagram is having a current loop and you have a speed. All the block diagrams in DC drives, induction motor drives, synchronous motor drives, permanent magnet motor drives, you have one loop called current loop and you have another loop called speed. And the hero changes. The hero here is induction motor. In DC drives, the hero will be DC motor, and in synchronous motors drives, the hero will be synchronous motor. But the remaining structure remains the same. So why do we need closed loop drive? If I take the example of textile mill or paper mill. In textile mill or in paper mill, I want constant speed. If the speed of the motor in textile mill is increasing, then the paper will break. If the speed of the motor is less in a paper mill, then thickness of the paper will be increasing. Then the owner will be losing the money. So you have to run exactly at constant speed so that the thickness of the paper will be uniform or thickness of the cloth will be uniform. So if I want to maintain constant speed, I have to go for a constant speed loop. I will explain you speed loop, temperature loop, then I will come to this. So example for speed loop, yourself driving a bike. So you are pestering your father for a bike and he has given you a bike, because he could not withstand your pressure. But the condition, you have to drive at 40 km/h. Your father has given you a two-wheeler But he says you have to run at 40 kmph, that is called set speed. Your father is setting a speed that is also called reference speed. Reference speed or set speed means the speed what you want. And I assume that you are a very obedient son or very obedient daughter. So you are driving in the highway. Whenever speed goes above 40, that reminder comes to you. My father said I have to drive at 40, so you will reduce the acceleration. Whenever speed goes below 40, your young blood is boiling and you increase the acceleration and you go to 40. So if I assume that you are continuously driving at 40, then I say it is a constant speed bike or a constant speed drive running at say 40 kmph. That is example for closed loop system. Example for open loop system. An arrogant boy or a blind and deaf fellow. You have given the vehicle to a blind and deaf fellow. The speed has increased from 40 to 60. His eyes are not working, he cannot look at the speedometer. His ear is not working, he cannot see the sound. So from 40 he has gone to 60 and he is driving at 60. He is maintaining a steady state error of 20 kmph. So a blind man and an arrogant fellow driving the vehicle, it is open loop. An intelligent or wise man driving the vehicle is closed loop. Then another example for temperature loop. Every day at home, in the night, you are fixing your temperature remote at 20 degrees centigrade. Let us say you are very comfortable with 20 degrees centigrade. You have fixed your remote at 20 degrees centigrade. So whenever temperature goes above 20, the compressor in the AC is on, takes the heat away. And whenever temperature is equal to or less than 20, the compressor is on. So you are nicely sleeping at home. One closed loop temperature system is working in your room and makes the actual temperature is equal to set temperature. So in your room or in your refrigerator, you have a constant temperature loop. And now in your drive, you have a speed loop and you have a current loop. If you have speed loop alone, it is not sufficient. Because to maintain the speed constant, you are changing your alpha. In the process, the current should not shoot up. Therefore, you want to regulate the current. To regulate the current, you have a current loop. What is the function of speed loop? We have said the speed loop will make sure that actual speed is equal to set speed. What is the function of current loop? The function of the current loop, it will help you to maintain constant current so that the devices will be very safe. You know, induction motor is very rugged and robust. But semiconductor devices are very sensitive like you. Even small overload semiconductor device will get damaged. Your brothers are working in the project center, project room. They have some 20 MOSFETs in their pocket. So the device is burnt like popcorn. So whenever a device gets damaged, they will take one MOSFET and put the new MOSFET. So semiconductor devices are very sensitive to overcurrents. Therefore, you have to put a current loop and maintain current at a safe level. Current loop will ensure that the current does not exceed the rated current. Now, we will assume that the load is increased. Some disturbance we will consider. Load on the motor is increased, speed decreases. So speed error is set speed minus actual speed. Speed error increases. Any correction should be done slowly. To bring that slowness, I have introduced PI controller. This PI controller is similar to this one. This door closer is there. This door closer is nothing but PI controller. If I don't have this door closer, if I put a spring and I pull that and someone is standing, the door will go and hit the person on the other side. I am keeping this is a mechanical PI controller which will slowly close the door without hurting the person on the other side. If you are angry with your brother or sister, you do not scold immediately. You have PI controllers in your brain, apply the PI controllers. Slowly you tell them. If you scold them, they will also scold you. So in a drive, I should not immediately take action, slowly I have to take action. So So my speed error is an indication of how much current it is required. Your phase in the evening is an indication of how much you are loaded, and your mother will give you that much of food. So like that, your speed error is an indication of how much load current is required. I see the actual current, then I adjust the alpha. I will reduce the alpha. If I reduce the alpha in AC chopper, I apply more voltage to the induction motor, then the speed will increase. Because I increase the load, instantaneously the speed decreases. The action of the closed loop system is such that the speed is brought back to normal speed or the set speed. So VYF control, I think commercially available drives. If you go to any industry, you find a VYF control, the big box. I think in your power electronics lab, we have a VYF control. You must see the demo of that. Then only you will appreciate whatever I have explained today. Inching, jogging. You press that jogging button, motor runs at slow speed. You press the inching button, motor moves in steps. All that you can see. If you take the demo of a drive, kirloskop drives are available. ABB drives are available. So if you look at any of these drives which are in the form of a big module, in that module you have that brake button, inching button, jogging button. You press them and then see them. So what is V by F control? The ratio of V by F represents flux. So if I increase V, I have to increase F. If I decrease V, I have to decrease F. So that my V by F ratio remains constant.